learn about the various tools that are available for generating a presentation like this, AI based tools. And I was very pleasantly surprised at how well some things work, but some things do not work very well. Actually, if I had written, I'm because I'm an engineer by training, the presentations that I usually create are pretty boring. They have a title and they have a set of bullet points on each slide. So these are visually a lot more engaging, but creating slides in that old-fashioned way, I think lends to a better flow of ideas. So pardon me if things are glitchy, I'm jumping from one topic to another, so on and so forth. I'll try to bridge the gap by talking about it, but I may not be able to do it. So be the judge. You tell me which parts worked well, which parts didn't work well, and so on. And I don't know how you guys run these meetings, but I like to be interrupted for questions rather than me talking for a whole hour. It would be nice if there was a mechanism using which you could interrupt me and ask me questions as I was going through this material. So moving on. Um, Let me talk a little bit about the AI stack or the AI ecosystem. I mean, when we talk about artificial intelligence today, and think about the whole, set of ecosystems, there are many different companies researchers, uh, universities, etc., work on AI. How are they stacked? How what's a useful way to categorize these? So you can think of it as a stack. Um, and at the very top are customer facing apps like ChatGPT or Perplexity AI, which is or Google's Gemini, or Ola's Krutrim, right? So these are customer facing apps where customers, users can pose questions, can ask to generate images, can ask for a text description of a video, many different tasks that, or somebody like me who wants to create
Sorry to
a
interrupt you,
slide.
sir.
Yeah.
Sir, you can share your PPT now. The PPT isn't shared.
You are not seeing my PPT? So can you see my screen at all?
No, sir, no.
You all could not see my screen at all?
Please share your screen and share your
Okay.
PPTs.
Hold on. I thought that I'm really sorry. I thought that my screen was already shared. Uh, you should have interrupted me sooner. Anyway, it doesn't matter. We can start again. I'll quickly go through. Is this better now? Okay. So
Yes.
this is the first slide. I'm sorry about that. I should have checked first whether you all can see me or not. I just thought that you could. Anyway, this was the funny meme that I was talking about. सब मर जाएंगे सिर्फ AI बचेगा. So this was the first slide. The second slide was a bit about me, which you all know about. Um, I should have mentioned Aurangabad there, but it's not there. The third slide is about what we will cover today, which is the history of AI, multimodal AI, and societal impact. The fourth slide was this note about this whole presentation being generated by AI. And please interrupt me for questions. And this was the slide that I was on, which is the AI stack or the ecosystem of the AI, right? So right at the top are customer facing apps, or let's start from the bottom, right? So at the very bottom are the GPUs, TPUs, and NPUs. So how are these chips different from a general purpose CPU? So a general purpose CPU, which is at the heart of your computer, is basically used optimized for running serial instructions, right? Each chip has an instruction set. The compilers compile your programs into code that can be serially executed. Typically, there are multiple cores these days on CPUs, and many threads can execute in parallel. Many programs can execute in parallel. The operating system figures out how to parallelize your program and schedule them on the CPU. So CPU is a general purpose chip that has a large instruction set. The GPUs, TPUs, and NPUs are specialized chips that are uh, optimized for the kind of things that AI models, the kind of operations that AI models need, mostly matrix manipulation functions. And initially, these chips were used for driving the displays, for the graphics displays, which are mostly large matrices. So that's why the GPUs were uh, found to be very efficient for running the machine learning parts of machine learning algorithms. And that's how the rise of NVIDIA, because NVIDIA was initially a graphics processor company, and now it's an AI processor company. TPUs are, Google makes TPUs. NPUs are neural processing units, which is the new architecture that is coming up. We'll talk more about that. So these are the chips. Now, these chips sit in computers, in architectures and buses and ways of accessing memory and so on and so forth that are also novel. And they are typically power hogs. So they need to have cooling that is, again, a lot of research is going into how to cool these GPUs. People have water cooled systems. They have water immersed systems, water um, uh, uh, interesting fluid mechanics and thermodynamics is being explored for how to cool these systems. Now, these systems sit in data centers. Again, data centers, you need to figure out how to provide them power, how to provide them connectivity, how to cool them, and so on and so forth. So there are data center vendors, which are basically cloud providers, right? Like Amazon, Google, Azure. Um, and on top of that, there are the model developers. So people like OpenAI, people like Google, people like Facebook, Meta, um, who actually develop the fundamental large language models, and they have a bunch of PhDs. They have hundreds of millions of dollars using which they can get a bunch of GPUs, and they have the capability uh, to scrape the whole web and other sources of data. And these three are the inputs that are used for developing fundamental models. Now, this could be language models, this could be graphical generative models, but these are all fundamental models that are being developed, need a bunch of money, a bunch of data, and a bunch of uh, people who know how to train these models, how to push the boundaries of the techniques that are needed, etc. Once the model is trained and it has its constants, then you have to host this model. And there are companies that host the inference, these models. That process is called inference. So companies that host the inference, like again, like OpenAI. And then there are customer facing apps, like the app that I used, for example, for generating this slide, that make calls into these customer facing apps and do the work that end user like me wants done, right? So this is how the AI stack looks like. I want to talk a little bit about Krutrim, which is a company started by Ola Group. And it's an ambitious company that wants to play in all these layers. They are working on designing their own TPUs. They are working on building their own data centers. They are engaged in an effort to uh, gather a whole bunch of Indic language specific data, because they want to be an AI provider that is specific to India. And the data sets that companies in the US are using, for example, are very sparse in Indic languages. Similarly, if you ask a generative AI graphics model like Hugging Face to create an image of a man or a woman, the chances are pretty high that it's going to show you a Caucasian a man or a woman. And an Indian AI system needs to be trained with India-specific data so that what it generates is more suitable for India. So Krutrim is doing that. They will also host inference on their own data centers and make it available either to end customers or to other businesses. And they will also build customer-facing apps, and they will allow other customer-facing apps to make API calls to their inference hosts. So this is the AI stack or AI ecosystem. And I'm really happy that a company like Krutrim is sort of has the ambition to build an end-to-end AI provider for India. Any questions so far? Okay, I'll move forward. So this is a little bit about the hardware, right? So there are specialized processing units like GPUs and TPUs. Then there are neural processing units, NPUs. Then there are field programmable gate arrays, FPGAs, and app-specific integrated circuits, ASICs. And the really cool advance now is that the training cannot happen on your mobile devices, but there are small language models, and there are some models that can actually run on the, by run, I mean the inference part of it. Once the models are trained and you know the constants, the models are small enough, or the phones that we carry in our pockets are powerful enough that the inference can actually happen on the phone. So the data doesn't need to across the boundary of the phone. It doesn't need to be sent back to the servers for running inference. The inference can actually happen on the phone in your hands, and that's very exciting. So edge computing and on-device AI has become possible. And quantum computing is a field where, I mean, that's we are already living in science fiction. I mean, I really don't understand how quantum computing works. I need to learn. But again, quantum computing has the potential to let us do parallelism at an unprecedented scale, and that will allow us to run that will allow us to run AI training as well as AI inference at rates that were unimaginable before. And if we are to reach AGI, that's something that we absolutely going to need to do. Because if you look at the amount of power that is used today for running AI, you will realize that it's extremely inefficient if you compare it to the human brain, right? It's about uh, like 1,000,000 or 10 million times less efficient to do inference on forget about training. I'm only talking about inference. Uh, to do it using the hardware technology that we have today. And if human beings, I mean, if we can do it, there must be ways to make this more efficient. And it's going to happen. I mean, we will figure out how to do it. You know, there are obvious inefficiencies in today's architectures, and people are already working on better architectures that will allow us to run inference and run training in a more energy efficient way. But if we want to actually have AGI, we are absolutely going to have to solve this problem, and we will solve them. This is just a funny little slide. I wanted to put the logos of all these companies: NVIDIA, which makes GPUs, Intel also makes GPUs and TPUs, AMD the same thing. Google has its own TPUs, AWS IBM, Meta, they all have their own hardware that that makes training and inference efficient. So I wanted to create a slide with the logos of all these companies on one page. So so I asked gave that as a prompt to uh, to a AI uh, that I was using for doing this. And uh, rather than generating a slide with those multiple logos on it, it generated this one image, which is sort of a composite of all their logos. I thought that this was interesting and funny, so I just decided to put this slide here. Um, Now we are going to switch gears a little bit, and we are going to talk about a brief history of artificial intelligence. Okay. Uh, in 1940s, neural networks were born. Uh, well, neural networks were not really born. We actually understood how our brain worked, right? Um, they developed, Warren McCullough and Walter Pitts developed the mathematical model for a biological neuron, right? We have neurons in our brains, and the coolest thing about a neuron is that whether a neuron fires or not, a neuron is sort of connected to all its neighbors, and whether a particular neuron is going to fire or not depends on the state of its neighbors. And whether the neighbor is going to fire or not, again, depends on whether this particular neuron is going to fire or not. So it's a really cool system, which, I mean, I remember the excitement that I felt when I first read about it. Um, must have been in school, uh, that, you know, that whether you fire or not depends on your neighbors, and whether your neighbors are going to fire or not depends on you. So it's a really interconnected system, and all our consciousness, all our memory, all our feelings, all our understanding of the world comes is sort of predicated on this really simple hardware system, right? And these guys figured out the mathematical model for a biological neuron, how that works. And once they did that, people almost immediately started thinking about, wow, this if this can be represented mathematically, why can't we build artificial systems which have the same properties? And if we can build artificial systems that have the same property, why can't these systems reason and think and possibly even feel like we do, right? So that started in 1940s. 1950s was an interesting development. Alan Turing, who was absolutely a genius. You should read his 1934 paper, I think. It's a very readable and understandable paper about a general purpose computer. I mean, this guy was a genius. I mean, he wrote it even, I mean, before transistors were around, even before the valves that we used to have in old radios. You know, that is what was used for electronics before transistors came around. I don't know whether even that was invented, but he theoretically figured out how a general purpose computer will work just based on zeros and one back in 1934. And there is a brilliant paper by him. I recommend you all to read it. It's very understandable. It's very accessible. But the same guy in 1950 came up with the Turing test, right? What is the Turing test? So the question that people were debating was that, can human ever can a computer ever become as smart as a human? So Alan Turing said that, you know what, let's forget about, I mean, that question is a complex question to answer. That goes into what is a human, what does being a human mean, and so on and so forth. Let's not do that. Let's just create a room, and you can communicate with whatever entity is in that room just by writing questions and passing it through a window, and an answer would come back to you, you know, through the window. And if the whatever the entity is in that room makes you believe that it's a human, then you can say whether it's a human or a machine. If it happens to be a machine, and if the person who is talking to that this entity through the window believes that it is talking to a human, then you can say that that entity is as smart as a human. And that is the gist of the Turing test. Alan Turing came up with in 1950s. And that has been used as a sort of a functional description of a smart machine, right? Whether it can fool a person into thinking that it's a human, right? So whether it's intelligent, actually intelligent or not, whether it has actual consciousness or not, whether it has any internal life or not, all those questions are kind of sidestepped. And because we don't know anything answers to those questions about anything other than ourselves, truly, right? We just take it on faith that anybody else who is a human being has more or less a similar kind of internal life that you or I have, but it's taken on faith. So Turing did the same thing, and sort of codified this in Turing test. Um, 1956 was the birth of artificial intelligence. Now, I mean, you can see that this was like 70 odd years ago, 68 years ago. These people did not have a lot of hardware that we have. These people are working with like really, really primitive computers, but they have the foresight, and the they have the vision to think about artificial intelligence. I really find this very moving. And so this was the proposal for that. There was in 1956, there was the Dartmouth University organized a Dartmouth workshop, which is considered to be a founding event of AI research. And this was the proposal, right? It was a 2-month, 10-man study of artificial intelligence we carried out during the summer of 1956. Blah, blah, blah. Make machines use language, form abstractions and concepts, solve the kinds of problems now reserved for humans, and improve themselves. Look at the scale of the ambition. This is in 1956. Uh, so this was very cool. Um, Similarly, it's around the same time in 1950s, people tried to come up with very general purpose, very generic programs. One called Logic Theorist in 1956, which is considered to be the first AI program, and a second program in 1957, which was titled General Problem Solver, right? Um, Now, 70s and 80s, Marvin Minsky and other people from MIT, etc. I mean, there was a lot of hype in the 60s, 70s, and the actual results were pretty pathetic. Because nothing that these guys tried was actually working. They weren't able to build systems that could solve problems that were practical. Nobody could build companies on these programs, which actually were profitable companies. So 70s and 80s was sort of the AI winter. And in 1980s, I mean, I don't know if you guys remember. I mean, some of you are probably as old as I am, and I remember Algol and expert systems and backward chaining and all of that. I remember being really excited about backward chaining and inference and so on. And expert systems were really interesting, where you basically just coded these decision trees, and they had limited success. Like medical diagnostics, for example. Like if you think about how a medical diagnosis process works, a doctor asks a series of questions to the patient, and based on the answers that the patient gives, the doctor eliminates certain possibilities, and the doctor goes down this decision tree and comes to a diagnosis. So that was coded into expert systems. So the idea was that the knowledge that an expert accumulates over a certain number of years of training can be coded into a computer program and can help humans who are not equally trained get answers to questions in those domains. Um, and in 1990s, you really started seeing the resurgence of AI research with newer techniques. The computational power had increased, but also an internet had started to get built, right? And so access to data at a scale that was never imagined previously was becoming available to people. And that is what really changed the what was possible and created these new techniques of machine learning, just availability of internet scale data. Um, and from 2000s and 2010s came the breakthroughs in deep learning. Most of the deep learning techniques um, were evolved in that time. Again, as I was saying, internet, um, connected computers, availability of big data, and this saw advancements in computer vision, natural language processing, and game playing AI systems, right? Um, uh, I mean, the it was truly breathtaking, the kind of things that started to become uh, possible because of big data. I was at Google in 2005, and Google Translate, I think from early on, I mean, it has. I remember being amazed by the quality of Google Translate. I mean, these are the kind of things that we take now for granted, but back in the early 2000s, I remember how how um, remarkable it was when machine translation started to become pretty usable. Um, and in 2022 came ChatGPT, uh, which basically allows you to have human-like communication and interactions. And it's a generative model. Now I was not able to add some technical content that I wanted to add. I wanted to start with ANNs and then go to RNN and RNNs, and then generative models, which are basically all predicated on this particular kind of uh, particular kind of uh, 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 RNN, where you account for attention, and there is this paper called "Attention is Everything," and that's what this is about. Uh, that's what has made all these generative models possible, may they be in text or image or video. um, but those slides I missed. So what is multimodal AI? How are we doing on time? We have time, right? Okay, I'm going to assume that we have time and that one of you will actually stop me uh, if we don't have time. Um, So what is multimodal AI? Multimodal AI refers to text, speech, image, and video in input and output, right? Um, so enables AI to understand information from multiple sources. Um, it's really cool. It's a step towards AGI, right? AI systems that can process and understand multiple types of data inputs, text, images, audio, and video to generate more comprehensive and accurate outputs. Um, Used in natural language processing, computer vision, robotics. Robotics is a really big area where multimodal AI is used. It can improve speech recognition and sentiment analysis, and enables robots the environment using modalities. Um, and It's pretty cool. Um, Multimodal AI allows for more accurate and robust AI systems, improves user experience, enhances accessibility, and most importantly, it enables AI systems to handle complex tasks, right? But you also need large-scale annotated data sets to train and evaluate multimodal AI models. As you can imagine, just text or just voice or just video is easier to uh, train with and work with compared to multimodal AI. And uh, data fusion is an interesting problem, and also development of models that can effectively learn from and generate multimodal data. So there are different ways in which multimodal data is worked with. Either what people do is that they fuse the data before training the model. Sometimes uh, they train each modality differently, and then they fuse the partially trained models with with fused data, and do they finish training the models in the end. So there are multiple ways in which people handle this. Um, and I mean, if you think about the other senses that we have, such as we have a touch sense, we have gesture recognition. Those kinds of things will go into AI systems. Maybe one day we will have peripherals that can deal with smell, for example. And at that time, we can expect that there would be a modality for AI to deal with smell, right? Um, uh, so basically, human beings are multimodal, right? We process everything that comes to us simultaneously. So it's a natural step for AI to become multimodal. um, so the human cognition relies on the integration of different modalities. That's how human beings work, and multimodal AI is basically going to bridge that gap. um, uh, So this is why multimodal models are important. It is because they require they're very narrow, and our current models need so much power that to enable true multimodal AI systems that can take that will use data from multiple modalities. I mean, just the number of tokens, the amount of data that these will have to use is humongous. I mean, probably a couple of order of magnitudes, or maybe even more than the current data sets. And so the CPU, the number of GPUs needed, or the number of amount of power needed for training these models or even running inference is very high. So we are going to have to make this a lot more efficient if we want to actually go towards AGI, right? Um, Now I'm going to come to my I'm going to talk a little bit. Actually, let's stop here a little bit, and I want to take questions now. I don't want to continue to talk. So are there any questions? I'm going to randomly choose somebody to ask a question. How does that sound? Can I ask Atish Peshatiwar if you have any question? Atish, are you there? How
I have
about
a question.
Okay,
So
Rahul, go
what
ahead.
Amog.
Who has the question?
I have for myself,
Okay, great. Ask your question.
to what extent can AI replicate the creative process of human beings, and what are the key differences between AI generated creativity?
Can you start your video? Because I can't hear you very well. Probably if I can see you, I will be able to. Okay, let me just forget about the video. Let me just try to see if I can answer your question. Let me repeat your question. Was your question basically what are the differences in which the AI works today and the human brain works? Was that the question?
Yeah, my question was what are the key differences between AI generated creativity and human creativity?
So, okay, let me ask you a clarifying question. What do you mean by AI generated creativity?
I mean, till what extent can AI show the creativity as we do
I mean,
as
that's
humans?
a really good question, right? I mean, I asked, like, I talked about Krutrim AI a little bit earlier, and Krutrim AI, I asked it to write a poem in Marathi about a sunset. And it actually wrote one for me. I was very surprised. It was not a very good poem, but it was a poem. It knew how to rhyme things. It knew that it tried to invoke some emotions about end of the day and end of things and so on and so forth. um, so now, is that creativity, or is that just figuring out what sentence goes before the sentence before, right? I mean, we all know how the generative models work to a fair amount, how the training works and how the inference works and so on and so forth. um, the human, some people think that we are also LLMs, that we are not that different. I mean, we feel that we have complete, we have the experience of consciousness. We think that we are complex. We think that we have um, emotions, and we are superior to machines. But from a certain vantage point, we are no different from large language models. Is one view. But so I don't know if it's that easy to tell the difference in creativity today. I can probably tell you whether a particular poem was created by an LLM, or whether a particular poem was created by a human being, especially a good poet, right? Maybe LLMs have already become as good as bad poets, and there are a lot of bad poets, right? Uh, so, is there any difference between human creativity versus the creativity in that in the current state of art? um, I think that we as human beings are capable. I mean, what we subjectively experience as sort of a leap, you know, that you have a limited amount of data, and suddenly from your subconscious or somewhere you come up with an idea which actually is beyond what the data would suggest. And you form an experiment and you try to see whether that works or not. I mean, that kind of a thing is described by many creative scientists as how things work. That's a subjective description, right? uh, I don't know whether today's LLMs or today's AI that we have is capable of doing that. But it might just be a matter of more data and more CPU and more power, right? Um, we might get there. Who knows? I don't know if that answers your question, but that's the best I have. Anybody else? I think there was somebody else who had put their hand up. Does anybody else have a question? I'm looking at the chat. Dr. Purva Vaingankar. Anaghat Chaudhary. Whether ChatGPT will stop human thinking. Yeah, I don't think that. So let me just, I mean, yeah, Professor Vaingankar and Anaghat Chaudhary, they all have similar type of questions. And let me go towards, go to that. I mean, before going to a science fiction, um, let me talk about the societal impacts of AI, right? I mean, I think that's where you guys are going. So, we are at the cusp of a huge change that will happen to the society. I think a lot of low level service jobs are going to disappear. For example, call centers, in 10 to 15 years there will be zero call center jobs left. uh, in about the same time frame, a lot of low level programmer and analyst jobs will also disappear in the second wave. But on the flip side, it will be possible for a small team to start and run a successful company. You will not have to hire people. um, but what that means is that everyone will be able to look bigger and sleeker than they are, because they'll be using AI to create their website. They will have a AI based technical support. They will have a AI based customer support, and so on and so forth. But what that means is that if you have local knowledge and local relationships, you will be ahead of everybody else, right? And in my opinion, and at least until true AGI comes, there is no substitute for human creativity. You know, um, so that's my general feeling about this. So again, now this slide sort of tries to answer that question. So given that this tsunami of change is going to come to us, what can I do, right? Um, so you have to keep your brain turned on, right? You have to be curious. You have to learn deeply. Don't learn only to uh, answer the questions in the syllabus. Actually, try to understand the concepts. Learn to think deeply. Uh, um, Try to make positive impact in your environment. I mean, all of this, AI can't do it for you. You actually look at what the challenges are near you and try to make a difference. AI is a tool that will allow you to amplify your impact. And most importantly, some of us are going to benefit enormously, and some of us are going to lose out. And perhaps even in the same families, perhaps in the same community, some people are going to benefit, some people are going to lose out. So have empathy for people who are losing out to the AI wave in the short term. uh, that's what you can do. I don't think that there is a substitute for uh, thinking about uh, our specific situations, our relationships, our the economic relationships that we live under in the society, the political situation around us. There are a lot of these things that AI is not going to help us with. It's our own ability to think and our own ability to impact our situation. So I don't think that ChatGPT or AI is going to solve that for us. Um, um, but I think that AI will I mean, our lives are just going to get better in unimagined ways because of AI. Okay. I mean, it's just going to be just the way internet changed our lives, just the way cell phones changed our lives. AI is going to get, uh, AI is going to change our lives. We are going to have drugs that we could not imagine before. We are probably going to have kidney transplants and kidneys designed in labs, and all of this is going to be, AI is going to enable this. I mean, this is really cool, right? Because when you have, I mean, the impact of AI on gene technology, right? You wouldn't think, you would not realize why it is important. I mean, drug discovery and using generative AI for generating molecules that can be tried out, molecules with certain characteristics. Like, for example, I was talking to a company and they were trying to use AI for designing a molecule that can go through the blood-brain barrier, right? So we have this barrier in our brain, so only certain type of chemicals can pass through that. And what that means is that they need to have a certain shape, they need to have certain proteins. So a molecule that has that property and these other therapeutic properties, where it can glom onto certain dendrons or certain parts of our brain, generative AI can actually allow scientists to generate molecules of that shape, and then they can figure out the chemistry, um, and things like that. I mean, it's just exciting the ways in which drug discovery will be positively impacted by AI. We will have better diagnostic tests, ability to more accurately figure out, read the data from MRI and current diagnostic methods. We might even have AI solving nuclear fusion for us. And global warming, as you know, is one of the biggest things that the humanity is facing. And if we have nuclear fusion, we will have cheap, safe power, which does not generate carbon emissions. And that is sorely needed, right? But if we have AGI, we will have better physicists. We'll have actually better physics, because we as human beings have evolved basically to reproduce, right? Uh, our ability to think and perceive the world and think about it and model it, etc., the brain that we have is fundamentally evolved to survive and to pass on our genes. If we build AGI, which is a general purpose intelligence, and it probably can perceive reality in ways that we cannot, and it can come up with more fundamental physics that we cannot perceive. And if that happens, we might even have faster than light travel, and we might even have the stars. um, Before I talk about AGI and consciousness, let me see if there are any other questions. Google, Intel, are they AI hardware or else something? So Google has TPUs and Intel also has TPUs, or parts of GPUs. Rahul, did I answer your question, or do you have a follow-up? They have specialized hardware that makes matrix multiplication easier.
Sir, I had a question.
Please.
What specific skills and knowledge areas should current computer science students focus on to remain relevant and thrive in an AI-driven future?
Yeah. So again, I mean, these are what I put here on this slide is the more generic answer to your question, right? I mean, as an AI student, I don't need to answer this question for you. You can Google this and you will know, right? I don't have anything better than that. I mean, go to YouTube and look at the videos by somebody like Andrew Ng or somebody like Karpathy, right? And you will know the answer to these questions. Like, what are the hot topics? I mean, agentic workflows. Agents that orchestrate multiple LLM instances is the current hot thing. Or there's an architecture called RAG, that's the current hot thing. But you can find all this out by very easily by going to Google, right? But this will keep changing because the rate of change, I mean, if you follow AI, the what was relevant 6 months ago is not relevant today. I mean, one of the things that I wanted to show you was this. I wanted to learn AI, right? I had no idea what the state of the art was. So I actually wrote a small Python program that the government of India puts PDFs of the speeches of the finance minister on their website. So I downloaded all of them and I trained a chatbot to use that as a context. And the chatbot would answer questions about about Indian budgets going back 50 years. And I was amazed at how little effort that took, right? I was going to show that project to you guys. I was going to talk a little bit about it, but I did that about 6 months ago. And the state of the art has completely changed in the last 6 months. So anything that I answer in specifics today is not going to be really useful. What is going to be useful are these fundamental skills. Be curious, learn deeply, think deeply, and be engaged with your environment. That's what will really help you. Did I answer your question, at least to some extent?
Yes, sir. Thank you so much.
Okay, you're welcome. So, as we go towards AGI, what's going to happen is that we, in 50 or 70 years, we might actually have systems that we start wondering about whether these are actually sentient beings like you and me, right? And do they need rights? Do they need a personhood? And so on and so forth. So today, these are science fiction concerns, but for the students who are here, they will not be science fiction concerns in your lifetime. So I just wanted to say that as the last thing. And here are the tools that I used. I used slideshare.ai to create the slide. I used perplexity.ai to answer a bunch of questions that I had, and I also used Google Gemini. I have put my email here. It's jitendra.vaidya, not jiten.vaidya. And if you have questions, please write to me. I hope that this was useful. And thank you very much. I guess there is a feedback form that somebody has put on the chat. So I guess I will stop sharing my screen now and give it back to Shubhangi. Or Bharati. I don't know who's driving this.
As our esteemed speaker, Jiten Vaidya, wraps up his illuminating discourse on artificial general intelligence via multimodal machine learning, it's now my pleasure to invite Amog Nagarkar to deliver the vote of thanks. Amog, please join me in expressing our gratitude to Jiten for his enlightening presentation and to all those who have contributed to making this event a success. Over to you, Amog.
It's been an honor to be part of this session, and I would like to extend my gratitude to everyone involved. First and foremost, I would like to express my heartfelt appreciation to our distinguished speaker, Jiten Vaidya sir. Your insights have been invaluable, and your dedication to innovation is truly inspiring. I also want to thank Bharti Ravipati for her eloquent introduction, which set the perfect tone for today's session. Your words painted a vivid picture of Jiten's journey and accomplishments, and we are grateful for your contribution to this event. To our esteemed guests and colleagues, thank you for your active participation and engagement throughout the session. Your thoughtful questions and contributions have enriched our dialogue and made this event truly memorable. Last but not least, I would like to thank the organizers and everyone behind the scenes who worked tirelessly to make this event possible. Your hard work and dedication are deeply appreciated. In closing, let's carry forward the insights and inspiration gained from today's session as we continue to explore new frontiers in technology and innovation. Thank you once again to everyone involved, and I look forward to our paths crossing again in the future. Thank you, sir.
Thank you very much. Thank you for giving me the opportunity. Bye.